12.7 will be really easy. It's not a hard lesson. 12.6 isn't bad either. It's just more theorems you have to know. So 12.6 is all about segment lengths and not segments in the circle with the crust problems. Remember, we've talked about sectors and segments. We're talking about line segments today. So not segments in a circle, but line segments that are going to be drawn in circles. And they're going to ask you to find the lengths of those segments. And basically there's just 3 rules, and one of them you already know. So I'm going to start with the review of what we already know. On your theorem sheet, you can look and tell me which number this is. It's probably one of the first ones we talked about, where we said that if you have 2 tangents, what's the relationship between AB and AC? They're congruent. What number was that on your theorem sheet? 2. So yeah, one of the first things we talked about in here, the second thing that we added to our theorem sheet said that if you have 2 tangents coming from the same exterior point, they will be congruent to each other. Okay? So that's the first rule about segments. The next rule is right here, and that's our first theorem, and there's only 2 that's going to be in 12.6, so it's going to go pretty quick. The first one today, and what number are we on our theorem sheet? 15? Is that right? Okay, so this is 15. Okay, so number 15 of the things you need to know for chapter 12 is if you have a circle, and in that circle you have 2 chords that are drawn in the circle and they intersect inside the circle. This is very similar to what we talked about last class period. The difference is today we're not trying to find these angle measures or these arc lengths. We're trying to find the distance of these pieces of these line segments. Okay, so if you have 2 chords and they intersect inside the circle, so when they intersect inside, this is the rule. In order to figure out the lengths of these pieces of these chords or the length of the whole chord, the rule is, and I'm going to label this a little differently than they do up there just to make it easier. The rule is you take one chord and you look at its 2 parts and you multiply them. A times B, and you set that equal to the other chord, the product of its 2 parts. So it would be A times B is going to equal C times D. And that's the rule. I usually say in words, part times part equals part times part. So you're looking at one chord and its 2 parts, and then the other chord and its 2 parts. If they intersect inside the circle, it's just part times part of one chord equals part times part of the other chord. Questions on that first theorem? Okay, and we'll work problems in a minute. And then the 16th thing you need to know, the second theorem that's in this lesson. I'm going to jump ahead in the notes. And before we can look at the second one, we have to talk about some vocab. So they're going to talk about and ask you to find on the homework a secant segment, an external secant segment. So you may want to turn in your notes with me to this slide right here so you can kind of follow along. Should be on the back maybe of the first page of 12.6. So first of all, we know that a secant intersects a circle twice. So when I look here, I can tell that PM is part of a secant because it intersects the circle twice. But the definition for secant said it was a line, that it goes on forever. So that's why they're calling this a secant segment, because it's just part of the secant. So PM would be a secant segment because it's part of the secant. NM is also a secant segment because it's part of the secant. PN is part of the secant, but we don't call it a secant segment. What do we call PN? A chord, okay? So there is a part that's going to be just a chord, but if it goes on past that, then those other parts are secant segments. One of those 2 secant segments, PM or NM, is called an external secant segment. Which one do you think is the external secant segment? NM, the one outside the circle. So NM is going to be the external secant segment. NM and PM are both secant segments. Does that make sense? Same thing on this other one. KM and JM are both secant segments. Which one of them is the external secant segment? JM. And I'm going to talk about that as being the outside part, the part outside the circle. Okay, that's important for our last theorem in section 12.6. So again, you start with a circle. But now notice where these secant segments intersect. Do they intersect inside the circle? Where do these two segments intersect? Outside the circle. So I'm going to say the same thing like I did last time. Where is it at? Is it inside or outside? The difference being if it's two tangents, remember they're congruent. So if it's two tangents intersecting outside, they're congruent. But if it's two secants intersecting outside, or even if it's a secant and a tangent, your notes are going to show this as a separate formula or separate theorem. I'm not going to write it as a separate theorem. We're going to write it as the same theorem because you can work it the same way. So it's less to memorize, okay? If they intersect outside the circle and one of them is a secant, two tangents are congruent. But if at least one of them is a secant or both of them are a secant, here is the rule. And again, I'm going to use little lowercase letters just to make this easier. So A, B, C, D. Same thing down here, A, B, and then we only have C here. Okay, here is the rule that you'll need to know. Let me write it in a different color. You're going to take the whole secant segment, this whole secant segment, so it's going to be whole times the outer part. What is the outer part of this secant segment? This is the whole thing. What part of it is outside the circle? D. So just this part. So it's going to be whole times outer equals, then you're going to go to the other secant segment, and it's going to be the whole times just the outer part. What's the outer part of the second one? D. So when we talk about the outer part, we're talking about the part outside the circle. So let's actually put letters in here for this formula. And this is where some students make a mistake. Be really careful. If I want to find the whole thing here, what do I do with A and B? Add them. Be really careful. Where I see most students make a mistake is they write A times B, especially when there's numbers plugged in here, like a 2 and an X. Every year, students will put 2X instead of 2 plus X. You add them. Remember, it's segment addition postulate. Part plus part equals whole. So this should be the whole thing would be A plus B. And one more time, what's the outer part? B. So it's the whole thing times the outer part equals, go to the next secant segment. What's the whole thing going to be called? C plus D. Good. And the outer part is just D. Okay, so there's two main new formulas today. If they intersect inside, you just do part times part equals part times part. If they intersect outside the circle, it's the whole thing times the outer equals the whole thing times the outer. And in my other classes, we shortened this to whoa equals whoa. Whole times outer equals whole times outer. Okay? Any questions so far? All right, let's work some problems. Again, sorry, I need to show you one other thing I forgot. This little section here. They're going to write this as a different theorem in your notes. If you skip ahead in your notes right here, they talk about a tangent segment. A tangent segment's just like a secant segment. It's just part of a tangent. So we already know that these are congruent. I listed that earlier on the board. If there's two tangents, they're congruent. A tangent segment is just part of a tangent. But they write a different theorem if it's a secant and a tangent. I don't think you need a different theorem. We already said it's the whole times the outer. So are you with them that this would be the whole thing AC times the outer part BC? Is everybody okay with that? Okay, but what happens when you have a tangent? What is the whole and the outer? They're the same. So it's still the same. You can still just do whole times outer. Whole times outer just turns out to be the same thing. So they say that's going to be that distance squared. But you can write it as just whole times outer. You're just going to multiply something by itself. So I don't really see it as memorizing another theorem. Just remember, so on our picture up here on the board that I drew, this would become, what's the whole thing? Careful. A plus B. What's the outer part? B. So whole times outer equals whole times outer. So what's the whole thing on the tangent? C. And what's the outer part? C. So it's just going to become C squared. But you don't have to even memorize C squared. You can just multiply C times C. Okay? Questions? All right, go back to the front of your notes. Let's work through some problems. And I tell you what I'm going to do. Same thing we did last time. I'm going to tell you, first of all, I want you and your partner to just give you about 10 minutes or so, and I want you guys to see how many you can work through. I'll come around, I'll help you, check answers, but start back at the beginning, not the warm-up. Skip the warm-up. Start here with example 1, and I'm going to give you 10 minutes and just work as many problems as you can do. Do not worry whether or not everybody else got the answer correct and you didn't. You need to say, hey, Lashley, I don't understand. Work the problem, please. And I will be happy to work it. But if everybody has the right answer, then it's just really wasting your time for me to stand here and work the problem, okay? So on this one, first of all, it said find the value of x. What did you guys get for x? 5. Does anybody need me to work and show how we get 5? Okay, if that's all you have written down, you didn't finish the problem. Read your directions carefully. It said find the value of x and the length of each chord. So what are the names of the chords in the picture? Okay, so you have x equals 5, and then you were supposed to find GH and EF. Be very careful. The most common mistake I see is that you've got in your mind part times part, and so then when you go back to find the lengths of those chords, it makes you want to multiply them. But the length of something is just the sum of its parts. Part plus part equals whole. So GH should be 14 plus x, which was 5. So what did you get for GH? 19. And then EF should be 10 plus 7, which is 17. Make sure that you're putting all of that as your answer. And do I put line segments above there? No. All right. Next one. We're going to skip it for just a minute. We'll come back to this one. It was the harder one. I think a lot of you are still kind of not sure about that one. So let's go to this one and see if you got it. What did you get for the value of x here? Should be 6. Raise your hand if you need me to work this one, though. I didn't see 100% correct answers when I was walking around. Anybody want me to work on how we got 6? Nobody needs me to work it? Okay. If you only wrote x equals 6, you didn't finish the problem. It also said find the length of each secant segment. So now go to the picture. Remember that you have chords, which are not secant segments. Obviously, you don't need to list the outside ones because you already know those values. So what are the 2 secant segments they're wanting you to list here? GE and DE. The part of the secant that we don't know the whole value for. Sorry, part of the secant that we don't know the whole value for. So GE and DE. All right, and once again, be careful that you add the parts. So if x is 6, what is the whole length GE? 14. And DE? 16. So again, make sure you're putting all of that as your answer. Questions here? Okay, moving on. Last one, I want to warn you about Algebra 2, what you learned in Algebra 1 as well. So first of all, what did you guys get for x? Did anybody get anything other than just 10? It's not 5 squared, it's a 3, but we'll work it and see. It should have been plus or minus 10. So let's work the problem and then remind you, but for geometry, can x be a negative 10? No, because it's representing a segment length. But in Algebra 2, it's not going to be representing necessarily a segment length, and so it can be -10. And I just want to warn you not to get in that bad habit of only putting the positive. We are so bad in geometry because we think, well, our answers have to be positive because we're talking about angles and line segments. But they don't have to always be positive in real life. And so when you're working those algebra functions and problems where it could be negative values, you've got to be careful. So let's work this one. Again, they intersect outside the circle, so that tells us to use the whole times outer equals whole times outer. So whole times outer equals whole times outer. What's the whole length here for ML? 20. What is just the outer part? 5 equals, go to the other line segment LK, what's the whole thing? And what's the outer part? X. And so that ends up giving us x times x is x squared. And 20 times 5 is 100. Okay, and then from here you took the square root. But you have to remember what you're really asking yourself is what squared is 100? Well, that could be +10 or -10. So your answer, anytime you take the square root of both sides of an equation, should be plus or minus. And then in geometry, you look at the problem and ask yourself, can it be a positive and a negative? And in this case, it can't. So for the geometry problem, we just list the positive. But sometimes it can be a negative. There are problems you're going to have on your homework and that you have had this school year on your homework where X did turn out to be a negative because when you plugged it in, it still gave you a positive length. So always check. Questions on this one? Does that make sense, Angelina? Okay. Everybody else good? All right, so let's go back to the one that we skipped. That was the harder one, the art project. Question? Okay, so it says the art department is contracted to construct a wooden moon for a play. One of the artists creates a sketch of what it needs to look like by drawing a chord and its perpendicular bisector. Find the diameter of the circle that is used to draw the outer edge of the moon. One of the first, or not really the first, let's see, I'm going to cheat off of Peyton's. I believe it was the fourth thing we talked about. Fourth thing on your theorem page, one of the early things we learned in the first section, I believe, was if you have a piece and it is perpendicular to the chord and it bisects the chord, what does this have to be a part of? What are we guaranteeing that this little piece is also a part of? Say it again. Well, we could make a right triangle, that is true, but that's not what the theorem told us. It has to be a part of the diameter. We said it kind of the other way when we wrote it. We said that if the diameter or part of the diameter is perpendicular to a chord, then it bisects the chord. But it goes both directions. So if a piece is bisecting a chord and it's perpendicular to a chord, then that piece has to be a part of the diameter of the circle. And what they want us to find is the diameter of the circle. Okay, it is not this length here. If you were to take a compass and try to draw the outer edge of this moon, you wouldn't be able to put your compass point here, sorry, can't touch it, and trace that correct and draw that circle correctly. It's going to have to come down here somewhere to get the radius that would really make that arc. So it's not the 18 inches. Everybody with me there? Okay, so here's some things you need to understand because they didn't do a very good job labeling the picture. 18 is this whole dashed part. If these are congruent, what does that make each of these pieces? 9 and 9. Everybody okay with that? Okay. Second thing they did not do a good job of is labeling what the 8 inches goes to. They should have put a little mark here to show you that the 8 inches is all of that. Or at least worded it in the wording somewhere. So 8 inches is referring to all of this. We know that if we keep going, we're going to create the diameter if we go all the way across to here. So if we kept going with our circle, which is not a very good job there. If we kept going with our circle, the diameter would go across it. So let's take what we learned today about these chords. I've got this chord intersecting this chord, which turns out to be the diameter. Where do they intersect? Inside the circle. So what's my rule going to be that I'm going to use? 15. Part times part equals part times part. Let's start with the one that they gave us that was 18. What are its two parts? 9 and 9. So we have 9 times 9 equals, now go to the other chord. This one is 8. What are we going to call this? X. So we have 9 times 9 equals 8 times x. Problem isn't really mathematically hard, it's just hard to understand because they didn't label things very well. Okay, so we have 9 times 9 is 81. That equals 8x. Divide by 8, and what do you get for x? 10.125. Is that the diameter? No, that's part of the diameter. We know that this has to be on the diameter, so all the way from x to here is the diameter, which means we need to take that value of x and do what with it? Add 8. So just add 8 to that, and we end up with our diameter is equal to 18.125. And what are the units? Inches. Questions anywhere on 12.6? Okay, the only thing that concerns me is you knowing these 16 theorems that you have right now by the time we take the test, because it's a lot of information, right? It's not hard stuff once you start working the problems. It's just a lot of information. Okay, let's go to 12.7. 12.7 is all about writing equations of circles. It's really a pretty short, easy lesson, and we're not going to do every example in the notes. By the way, right now you have enough information to complete the homework assignment I gave you last class period, right? Okay, so that's going to be due on Tuesday. Assignment 21 is due Tuesday. All right, we're going to skip the warm-up again. We're going to look at our objective here today is just simply to write an equation of a circle and graph the equation of a circle on a coordinate plane. You will need graph paper, so make sure that if you don't have some still in your binder from earlier, that you grab some before you leave today for your homework, okay? All right, so first of all, I'm going to go through and give you the standard form of the equation of a circle. If you want to know where it comes from, here is the proof of where that comes from by using the distance formula. But to save time and to give you some time to work on homework today, I'm not going to go through and explain this whole thing. What you need to know is this part right here. What is the equation of a circle? And I'm going to flip it around. So what I want you to know, and you can add this to your theorem page if you want to. This is a formula you are going to have memorized for the test. So you could call this number 17 if you want to. I'm going to write it on the board over here. Number 17. You need to know the standard form of the equation of a circle. And this is what we're going to spend more time on Tuesday, is writing equations in standard form. Today is going to be a little easier. So the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. X minus h squared plus y minus k squared equals r squared. It's down here in your notes, but I flipped it around. Okay? Now, what do these letters stand for? So first of all, you need to know that the center of the circle is at the point h, comma, k. The center of the circle is at h, comma, k. And r stands for, what do you think? Radius. But be careful. R is the radius. What does the formula have happening to r? It's squaring it. So if they give you a number here, like let's say that my equation was equal to 25, my radius is not 25. What is my radius? 5. It's the square root of this number. Be very, very careful. Where students get confused is when they give you something like it equals 5. A lot of students want to say, well, the radius is 5. The radius is not 5. The radius is the square root of 5, which might turn out to be a decimal number, and you just have to approximate about what that is on your calculator. Okay, so be really careful. R's the radius. The center is at HK. This is also something that confuses students all the time. So I'm going to put an example up here on the whiteboard. X minus 3 squared plus y plus 2 squared equals 16. Okay, notice the formula has minuses in it. The center is not the sign. The center is the number that comes after the minus. So the H and the K. So be really careful. What would be the coordinates of the center here? Close, but not quite correct. Part of what you said was correct, part of it was wrong. So if you didn't hear Kirsten, she said 3, 2. It's not 3, 2. What is the center? 3, negative 2. So what I usually tell myself is you have to change the signs. If this is x minus h and the center is at positive h, I'm changing the sign. If this is y minus k and the center is at positive k, I'm changing the sign. So instead of this being at negative 3, the center's at positive 3. And in order for this to have been y minus a number, that number must have been a negative, because minus a negative is what gives us a positive. So once again, I'm changing the sign. So the opposite of positive 2 is negative 2. So you can either think about it as what's the formula, or you can just remind yourself, always change the sign when you're picking out the center, and always change the sign when you plug in the center. Okay, and then what's the radius? Remember, this is equal to r squared. So the radius has to be the square root of 16, which is 4. Okay, that's the big idea for 12-7. You need to know the standard equation of a circle and then be able to pick out the center and pick out the radius. And then I'm going to ask you to graph circles, and we'll talk about what you have to show on your graph. Okay, so here it is in your notes. Here's your formula. X minus h squared plus y minus k squared equals r squared. Center's at hk. Radius is r. Let's look at some examples. Write the equation of each circle. So start with your formula. Write the formula down. The more you write it, the more you're going to memorize it. Don't try to just write the answer. So it should be x minus h squared plus y minus k squared equals r squared. Okay, what are we going to plug in for h? Because it tells us the center J is at 2, 2. So they're telling us that the center is HK, meaning that H is positive 2 and K is positive 2. So in for H, I'm going to put 2. So this becomes X minus 2 squared plus, what's going to go in for K? 2. So we're going to have Y minus 2 squared. Make sure you square them. That's the other thing I often see students forget to do, is square them. It's a completely different picture if you don't have squares. It does not create a circle if you don't have squares. Equals, if the radius is 4, do not leave this as 4 squared. Simplify it. What is 4 squared? 16. So I don't want you to leave it as 4 squared. Oops. Come on. Go back. Just kidding. I don't know, it's having a problem. There we go. Write it as x minus 2 squared plus y minus 2 squared equals 16. Simplify what your radius squared is. And that's it. That's all there is to it. Write the equation of a circle, plug in the center, plug in the radius. Pretty easy. Okay, let's look at some more where that's a little different. My goodness, I cannot quit blowing up the screen. I don't know why. Fat fingers today, I guess. Let's try this. There we go. Okay, maybe it'll let me now. Okay, this one's different. Nope, it's not going to let me. Give me 1 second. Close it out and start it back again. Mrs. Lashley? Yes, one moment, please. Haley, phone? Okay, sorry, back up here now. What's different here on this one? Okay, they give you 2 points. What's one of the points they give you? The center. Which one's the center? Okay, so they give us the center is K, right? 1, -8. They tell us it has a center of 1, -8. So they're giving us the H and the K. What are they not giving us this time? The radius. You're going to have to find the length of the radius. There's 2 ways you can do it. I'm going to show you the way that you might think of or that we've used the most. So first, let's start with our formula. Our formula is x minus h squared plus y minus k squared equals r squared. Okay, what's going in for h according to the problem? Say it again. 1. The center first number goes in for h, so this is x minus 1 squared plus what's going in for k? Okay, -8's going in for k, so when we plug in a negative, it's already a minus, so minus a negative is going to change that to a positive. So again, when you're plugging in these numbers, it's always going to change their sign. Instead of it being a +1, it's a -1. Instead of being a -8, it's going to be a +8. When you plug them in, it changes the sign. When you pick them out, it changes the sign. So the only thing we don't know is what is r, right? And that's what we need to find. There's 2 ways you can find r. The first way is to think about this graphically. So if you sketch yourself a little graph, we've got the centers at 1, -8. So our center's way down here, at 1, -8. And then we have a point that our circle's passing through at 6, 4. So if I were to draw my circle, it's going to be centered around that center and it's passing through that point. What do we call this then from the center to that point? The radius, and that's what we need to find. So who said distance formula? Okay, we could use distance formula to find the length of the radius. So one way to find the radius is to use your distance formula. Distance is equal to, your formula comes back to you from way back in the first few chapters, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The square root of all of that. Subtract the x's and square them, subtract the y's and square them, add them together, take the square root. Okay, so let's try that. We're using these 2 coordinates. It's going to go, what 2 numbers are we going to subtract for the x's? 6 minus 1 squared plus 4 minus a -8 becomes 4 plus 8, and we square it. Okay, what is 6 minus 1? 5 squared plus, what's 4 plus 8? 12 squared. What is 5 squared? And then 12 squared? Right, so 25 plus 144. What is 25 plus 144? 169, and then we're going to take the square root of that. What's the square root of 169? 13. So the length of our radius is 13. Questions on how we found that? Okay. When we plug that in, though, do we just put 13 here? No, what do we have to do to 13? Square it. So when we write our final answer, it's going to be x minus 1 squared plus y plus 8 squared equals 13 squared. And what is 13 squared? 169, what we had right before we took the square root. And that would be your answer. So if they give you the center and they give you a point that the circle is going to go through, that distance is your radius. So you just need to use your distance formula. Anybody want me to show them a different way you could find the radius other than distance formula? Are we all good with distance formula? Okay, then we'll just stop there and leave it at that. All right, let's look at graphing these circles. Oops. So here is our first example. They want us to graph x squared plus y squared equals 16. When you see an x squared and a y squared, you're going to think circle when it's separated by a plus sign. That's the graph of a circle. Remember, your formula is x minus h squared plus y minus k squared equals r squared. So for you to graph the circle, you're going to have to find the center and the radius. So when I look at this problem, what is being subtracted from x before it's being squared? When I compare it to this, what is being subtracted from x before it's being squared? H in the formula, but what in our equation? Is anything being subtracted from x before it's being squared? So what number is being subtracted from x? Not 1, or it would say x minus 1, 0. So that means that h in this problem is 0. What is k in this problem? 0. So if h and k are both 0, what is the center of this circle? 0, 0, the origin. Does that make sense? That sometimes you're not going to have a number being subtracted because it's 0. All right, and then if 16 is r squared, what's the radius? 4. Make sure you take the square root of that number. That's one of the most common mistakes I see. So my radius is 4. All right, and did I give you guys graphs on your notes? Okay, so what we're going to do when we graph these, use graph paper, don't draw your own graphs. You're going to plot your center, and I want you to list the coordinates of your center. You can either do it on your paper or you can do it out to the side like I did here. Okay, so list the coordinates of your center and list your radius. Then go out that distance from your center in all 4 directions. So you're going to go 4 units to the right, put a point, 4 units up, put a point, 4 units left, put a point, 4 units down, put a point. Then, if you are circle challenged, you have very difficult time drawing circles and your circles turn out to look like squares or diamonds or rhombuses, you need to get a compass. If you can make a circle that looks somewhat circular, like that, that's fine. It doesn't have to be perfect. But if your circles turn out to look like this, you need to get a compass, okay? That will not be acceptable. So what's in blue will not work. As long as it looks pretty circular, you're okay. Okay, and if you have trouble, you can grab yourself a compass and make them nice and beautiful. Questions on graphing? Okay, try the next one. What's the center of the next one going to be? Be careful that you're changing the signs. Very good. The center is not -3, +4. The center is +3, -4. Always change the sign. And the reason you're doing that again is because the formula has a minus in it. So h is not part of that. H is what's after it. Okay, and what's the radius going to be? Good. The square root of 9, which is 3. Go to your graph. Plot those coordinates and graph it. So we have a point at 3, -4. Plot that as your center. Again, I'm expecting you to list the coordinates for your center. So you can do that on the side of your graph paper, or you can do it on the graph, wherever you prefer, and list the length of your radius. So this needs to be listed on your paper, and then go out 3 units in all directions. So up 3, left 3, right 3, down 3, and then draw your best circle. Questions? All right, we're not going to do the one on the back, and that's the end of 12:7 and the end of chapter 12, except for the